In this lesson, we'll make some important observations about the binomial expansion of a plus b power n. Consider expansion of a plus b power n. Now, expansion of a plus b power n is usually written in this form. A plus b power n is equal to nc0 a power n minus 0 b power 0 plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2 plus so on plus ncn a power n minus n b power n, which can also be written in this form by some people. These combinations are written like this: nc0 here a power n minus 0 b power 0 plus nc1 a power n minus 1 b power 1 plus nc2 here and a power n minus 2 b power 2 plus so on plus ncn a power n minus n, which of course is 0 b power n. Or even we can use the summation notation, and in that way we can write it summation k is equal to 0 to n ck a power n minus k b power k. This is usually the way we will see binomial expansion of any binomial expression. Let's take a look on the index. What is the index in this expression is n. So observation 1. Observation 1 is that number of terms in the binomial expansion of a plus b power n is 1 greater than n, is 1 greater than index is n here. And the example of this is, if you want to take a look on this example, if you expand a plus b power 2, you will see 3 terms in this: a cube plus a square plus 2ab plus b square. There are 3 terms. So these are 3 terms, while the index is 2. So the number of terms is 1 greater than the index. Similarly, if you expand a plus b power 3, this would be a cube plus 3a square b plus 3a b square plus b cube, which contains 4 terms. This is 1 term, 2nd term, 3rd term, and the 4th term. But the index is 3. So the number of terms in any binomial expansion would be 1 greater than the index. And the second observation we make here, observation number 2, we make is the sum of exponents of a and b, the sum of exponents of a and b in expansion of the sum of exponents of a and b in any term is always equal to index n. Like if you take a look on this previous example, here the index of this expansion is 3 and a cube, there is power of b is 0, so 0 plus 3 is 3. And if in this term 2 plus 1 is 3, in this term 1 plus 2 is 3, and in this next 3. Like every term has the total degree, the sum of the exponents is always equal to the index. So that is another observation. And for observation number 3, this is very interesting observation. Coefficients of terms equidistant from beginning and from the end are equal. Coefficients of terms equidistant from beginning and the end are equal. So if there is an expansion here, let us take an example here. Example here is example number 1. If we expand a plus b power 4, by binomial expansion we are going to write a power 4 plus 4c1 a power 3 b power 1 plus 4c2 a power 2 b power 2 plus 4c3 here a power 1 b power 3 plus b power 4. Now from the end, this is, let's say this is the end and this is the start. Now this term here, this term is 1 unit away from the start, and this term is 1 unit away from the, so the distance from the end is 1, and here distance from the start is 1. What is coefficient of this term? So the coefficient here is 4, 1, and the coefficient of this term here is 4, 3. According to this observation, 4c1 is equal to 4 and 4c3 is equal to 4, which are equal. It means that any term which is equidistant from the beginning and the end, their coefficients are equal. And now the last term, the last observation, observation number 3, observation. So this is observation number 4. The in expansion of a plus b power n. General term is denoted by TR plus 1 and tr plus 1 mean r plus 1th term, this would be equal to ncr a power n minus r b power r. This is called general term because if we substitute the values of r as 0, 1, 2, 3 or up to n, we can find any term. And minor observations, observation 5 is in expansion of a plus b power n, exponents of a decrease from index to 0. So if the index is 3, the coefficients, the exponents of a will become 3, 2, 1, 0. So, and observation number 6 is that in expansion of a plus b power n, coefficients of exponents of b increase from 0 to index. So that is an easier way to remember how to apply binomial expansion, keeping in mind these observations. So let's do an example here. What is binomial expansion? What is binomial expansion? Expansion of a over 2 plus or minus 2 over b power 4. If we were to write binomial expansion of this, also write general term. So we can in fact learn how we will apply binomial expansion, and they could be applied on any binomial expansion. So if this is a over 2 minus 2 over b power 4, this would be equal to 4c0 a over 2 power 4 into minus 2 over b power 0 plus 4c1 a over 2 power 4 minus 1 is 3 into minus 2 over b power 1 plus 4c2 a by 2 power 2 times minus 2 over b power 2. So plus 4c3 a by 2 power 1 into minus 2 over b power 3 plus 4c4 a by 2 power 0 into minus 2 over b power 4. And in this case, now we are going to simplify each term. You can see that the coefficients, the binomial coefficients 4C0, 4C1, 4C2, 4C3 and 4C4 increase in a pattern, and 4C0 is equal to 1 time a by 2 power 4 means a power 4 divided by 16, and minus 2 by b power 0 means 1. 4C1 is equal to 4 and into a power 3 over 8 into minus 2 over b plus 4C2 is 6 times a square over 4 into 4 over b square plus 4C3 is again 4 times a by 2 times minus 8 over b cube plus 4C4 is 1, a over 2 power 0 is 1 into minus s. So this would become 16 over b power 4. It is simplified, and now we will further simplify it. So this will become equal to a power 4 over 16, and here this will get cancelled. 4 times 2 is 8 and this is 8, so this becomes minus a cube over b, minus a cube over b, and here this will become plus 6 because 4 will get cancelled with this 4. This will become plus 6a square over b square, and this becomes minus 16 a over b cube plus 16 over b 4. And if we wanted to write the general term, the general term mean tr plus 1, that will be equal to 4cr a by 2 power 4 minus r into minus 2 over b power r, and if we write it in that other form, this could be written as 4c r into a by 2 power 4 minus r time minus 2 over b power r. This is what is called the general term, and we can find any term just by putting the value of r. For example, if we were required to find the third term, then for finding third term, put r is equal to 2. So this would become T3 equal to 4C2 into a by 2 power 4 minus 2 into minus 2 over b power 2. So this will give us 4C2 will be equal to 6 times a square over 4 times minus will become plus because the power is even. So this will become 4 over b square. 4 will be cancelled with 4. So this gives us 6 a square over b square which is a third term in the expansion. That's what was required. But let's take a look on, we actually expanded this, and this, we know that this was the third term. So this was the term 3, and we can see that we have calculated the same term without actual expansion. So that way we can find any term. This gives us the required term without actual expansion, in full. So that is how we can utilize general term.